Okay, today we'll be starting some material from Chapter 12. The idea of the things we're going to cover in Chapter 12 are to give some of you are going to take AP Calc or Brief Calc next year, a little taste of what you'll see with some of these basic skills from Calc, okay? All right, so today we're going to work on finding limits with tables and graphs. So what's a limit? Let's write down this definition right now. Okay, here's the definition. I said read as. This is the part you might want to start with. So this is LIM for short. The limits of f of x as x approaches c equals L. Okay, start with that, and then we'll write down the how you read it. So LIM f of x, that's a little arrow, c equals L. This is going to be the y value. I'll pause and let you write that down. All right, and now how do we read this? This is read as, quote, the limits of f of x as x approaches c equals L. Okay, again, I'll pause, let you write that down. Okay, that'll be a key phrase we're going to come back to, approaches. It doesn't say the word at. The limit's about approaching c, okay? All right, now we're going to have a left-sided limit and a right-sided limit. So you can put this under the one-sided limit category. All right, so notice the notation is all the same, except the difference is this minus and plus sign right here, which we've had, like, they call it arrow notation back in Chapter 1 when we dealt with some of this, but there weren't limits. So if you see a minus sign up in the exponent area of c, it means coming in from the left. If you see a positive in that area, that means we need to come in from the right. It's not to the right, from the right. That's kind of a key word that you might want to add, right? From the rights or lefts. Okay. Okay, and a traditional limit, or just a normal limit, which could also be called a two-sided limit, means this. If the left and right-sided limits approach the same y value, then we say the limit does exist. And we'll name it, and we'll say it could be 5 or 4, whatever number it is. Okay, so if it does exist, we'll report the number. Here's the scenario where it does not exist. If the left and right's limits approach different y values, we'll say it doesn't exist. Okay, you'll see all this in action real soon. We're just laying the foundation, getting these definitions down for you. So again, I'm going to pause and give you some time to write that down. Okay, these definitions we'll be using all week. So very important. If you didn't get those down in detail, rewind the video and get those down. Okay, so let's get into this example. Find the limit of the function using a table of values. Okay, I added a couple of things in here maybe just to make sure we're clear. It says select domain values on the left and on the right of the x value, also referred to as the c value. Maybe you want to add that in there. So the left and right of this c value in the definition. They'll say as x approaches like 2 or 3. So that's the value they're talking about. All right, and then the limit exists if the range or y value is the same from the left and right in the table. Kind of what we talked about when limits do exist. They have to approach the same range or y value. Okay? All right, so let's take a look at this first one. Now there's an error here, and that's actually one of the main reasons for limits. Limits exist for these complex math problems, complex calculus problems that are sometimes undefined for certain x values. And they don't want to give up on the problem. They want to have a way to get through it and continue on in this complex math problem. That's why limits are here. So if I told you to just evaluate this function with 2, you can write this down if you want, just kind of a teaching tool though. So if we threw in 2 and figured out the math, I'd have 2 squared 4 minus 4, I get 0. And we can't divide by 0, it's undefined. Okay, so, but we can find the limit for this function as x approaches 2. And this is how we do it. We take a look at what happens from the left and right. And if it approaches the same number, we have a limit. So this table is all set up for us. It's pretty easy to do. once you get used to this table. As x approaches 2 from the left, what's the value when we plug in 1.99 evaluate? They give us that number of 0.501. Okay, even a number closer to 2, 1.999. What's the value? It's getting pretty close to just 1/2 or 0.5000, right? What about coming in from the right? Coming in from the right on the number line, these numbers again are increasing towards the same number. You guys see that? It's kind of like a fill in the blank. You know, what number is our best guess for filling in the blank? 1/2. Okay, so that's our answer. Here you go. Here's kind of how we'd write it down. The limit of this function, where we could write that. You can put the answer right here, though, I guess. The limit of this function as x approaches 2 is equal to 0.5. That's the answer. Okay. Now, I also need to show you how we can plug this into our calculator. If they give you a table like 1 and 2, it's pretty easy to figure out. Okay. You go ahead and take a look at 2. See if you can see if they're approaching the same number or not. And then I'll show you also how we can use our calculator to plug this in. Okay. All right, so this is a little different. Probably weren't quite ready for this, but it's okay. Let's go through what's happening here. So from the left, as x gets close to -1, look at these values. They're getting larger in the negative direction. And then from the right, as it gets close to -1, these values are increasing in the positive direction. What's happening is probably like an asymptote. Okay, take a look here. Like at -1, from the right, these values are getting larger. Here, they're getting smaller down to negative infinity. All right, so in that scenario, if they aren't approaching the same number, we say it does not exist. So write that in for your answer. I made a little note if you want to. They approach different y values. From the left and right, they're not converging on the same number like it did in number 1. Okay, so if they're not converging on the same number, our answer is does not exist. DNE for short will be fine. Okay, so for number 3, they didn't give us the x values. Let me show you how we can do this in our calculator. Okay, so grab your calculator now. And let's throw this in here. Your first step is you have to punch in the new function that we're dealing with. The limit of this function as x approaches 0 is what? So what we're going to do is go to your y equals, and let's dump them in there. Always separate your numerator from denominator in parentheses when you go do this, okay? So I've got 2x up top divided by 3x squared minus x. Remember, you got table features on Desmos too. If you don't have a graphing calculator, try Desmos. Okay, now what we want to do, let me show you the trick to setting up the table. You kind of want your c value to kind of be in the middle. So whatever the c value is, we'll put there. Just like up here, our c value was 2, right? And over here, it was -1. Put that in the middle, and then we'll take a look at a couple of small values coming in from the right and a couple of small values coming in from the left. All right, so here's what you should do. Go to your table setup. Okay, it's right here. See my table setup? Select that. Why don't you have your starting point, BC, so put in 0 there. And then we want small increments. Let's just go by hundreds. Hundreds usually always takes care of it. So I want my change in table to be 0.01. Okay, and we're ready. Make sure these are on auto. If you want to ask, I'll maybe demonstrate that when we need it, but I put these on. It's automatically going to generate it for us. So now I'm going to go to table, and now I've got values. Here's an x value of 0. I have an error, so we can say undefined or error here. And then what are a couple values coming in from the left? Here's some x values that we came up with. At -0.02 and -0.01, what are the corresponding y values that we can jot in here? -1.89 and -1.94. A couple decimals should be enough. Okay, I'm just copying down the table. These other values, 0.01, -2.06, and then the other one, okay, so kind of like number 1, as we're coming in from the right on the number line and coming in from the left on the number line, what's a value that might kind of fill this gap? we should see -2 kind of makes sense, right? So that's what we'd say. If it's obviously converging towards the same number, you usually just choose, it's not always a whole number. Sometimes it might be a fraction like number 1 was. We said 1/2. So the answer here is -2. Fill in the blank. Okay. Okay, let me show you how to do this piecewise 1, 2, and then see if you can try 5. All right, the piecewise one, same thing. Like we always put the c value in the middle. Okay, so let's do the same thing here. The limit of this function, this piecewise function, is x approaches 1. So let's put 1 right here. Okay, the piecewise functions, you just got to remember, they have conditions. Follow the conditions. So this says to use this function when what? When x is greater than or equal to 1. So greater than or equal to 1 is going to be here and here and here, because we'll use the same strategies I just did here. Let's just go up by just a little bit, like 1.01 and 1.02. Okay, you guys got that? So when x is greater than or equal to 1, I use this function. For the other one, it says when x is less than 1, I use this one. So this function, because if we use these small increments again of 0.01, I have 0.99 and 0.98. If I just subtract a penny, right? Add a penny, subtract a penny. So less than 1, I'm going to use this function here and here. And now I just need to evaluate. Okay. All right, so you could do this with your table, or if you're getting too confused with your table, you could simply grab your calculator, right? Go to clear screen and do 3 times 0.99 plus 1. Okay, our table could do that a little quicker, I guess, but this is just kind of what you're doing. 3.97 goes here. And then I could hit second enter and quickly punch over and hit 0.98, and I could get 3.94. Okay. But like I said, table work too. I just got to put that in y equals, and I got to change it out for this one. So for example, now that I have 3 of them, I'm going to go ahead and use y equals. So I'm going to put in 5x squared minus x. For another way to evaluate these, I'm going to start at 1 and then increment by 0.01 to make my life easier. Table set, start at 1, increment by a penny. And here I have an easy way to quickly identify these. At 1.01, there's my answer, 4.09 and 4.182. So I'm going to write those down. 4.09, 4.182. And actually at 1, it's not undefined this time. It was 4. So I can throw that in there too. Okay. So use the table, go to the clear screen, whatever. You just got to realize that this is kind of the cutoff, right? When x is greater than or equal to 1, I use that function, the other function over here. All right, so as x approaches 1, what values are these approaching? Definitely, sometimes we have an error message there. Sometimes we don't. You might actually have a value like this one did. Clearly, it's approaching 4. So that's the answer to this problem. Okay, let's have you try it for number 5. Okay, remember this is how you can get these values quickly. I got starting at -4, the c value. Here's my increment, 0.01. Go to table setup. I'm sorry, I'm at table setup. Go to table now. Oops, that's graph. Stop. There we go. So now I can quickly throw some values in here. -4, we're supposed to use 7 minus x for these 3 spots. And so there we go. I've got some values to throw in here now. 11, 11.01. Oops, that's it. 11, 11.01, 11.02. Okay. All right. Then I go to y equals and change the function to this. And now I can get these values right here. 16.92 and 16.84. Okay. Some of you may have put down 11 for the answer. That is incorrect. And it takes a while to get used to this. Limits, as the limit of f of x approaches c, not equal to c. So you almost don't even look at that spot. Just ignore it altogether. Okay? So what do these numbers approach? Are they approaching the same number? No, this is increasing towards maybe 17. This is decreasing towards 11. When that happens, we're supposed to say does not exist. So got to remember, don't look at for limits. It's as x